So we have seen how we can design the SDT depends on our requirement. If this 1 and 0 is depends upon whether you are counting the number of ones or number of zeros. If you consider number of zeros, I will just consider my count value equal to 1 for B to 0 and count value equal to 0 for B to 1. Just it will be opposite, right? Now, using this semantic rule, there are some certain problems sometimes come that the semantic rule will be given to you and an expression will be given to you and you have to evaluate that. But before that, let me remind you a very important thing again. That is, if you have a production rule something like this, assume that you have a production rule like E2 E plus T. Sorry. So E. Okay. E star T. Okay. No. E plus T. And say, or maybe, okay, E plus T. Then T2. Here I write, say, T star if, okay, or if, here it will be or T, and if will be some ID, okay. So if we have a production rule like this, so what you can basically generate, you can generate any form of any expression having addition and subtraction, right? So you can generate an expression like this. Now if this is your expression and if I have some value over here, when the computer start computing the result of this expression, the computer does not compute more than one operation at a time. For a particular code or particular process, I'm saying. So definitely one of these addition will be computed first, and then result will be computed with the next addition. There is another situation like I can generate something like this also. ID star ID plus ID. Now here also either plus or star will be computed first, but we have a very slight difference between these two expressions. Difference with respect to the property in the sense that in the first expression both operations are of same type, and here in the second expression the operations are of different type. Now what this computer is basically trying to understand first, that among both operation of same type, which operation should be executed first, and in the second expression computer is trying to first predict that among two operation of different type, which operation should be executed first. There is a slight difference, and this difference represents this particular problem that the computer has to solve first is actually technically what we call associativity. And this particular problem that this computer will basically solve first is called, what is we can call precedence. What is associativity? If we have more than one operation of same type in the in a particular expression, the computer has to decide, or somehow the machine has to decide, which operation should be executed first. And what is precedence? If we have more than one operation of different type, then the machine has to decide which operation should be executed first. And that entirely depend upon what grammar basically was used to generate this particular string, or what grammar was used to parse this particular string. For example, in this particular problem, like what I have written here, if I want to generate this string id plus id plus id, what will be my parse tree? I can generate something like this, right? E to e plus t, then again e to e plus t, then again this e can be written as only t, t can be written as only f, and f can be written as id. This is also almost in the same way. Now you see, I'm not going in detail how it will parse, because you know that already you have seen in my previous classes. But what I want to show you here, that you see, interestingly, since you know that how it will parse, that is top to bottom and left to right, naturally you will see that this e will be computed first, and then only this e can be computed. So this is number one computation, this is number two, and this particular string is generating the id plus id plus id like this. So accordingly, what you can see here, what is the left plus is actually executed first, then the right plus, right? So basically what you can say, that according to the grammar that I have used to generate this string id plus id plus id, this plus is left associative, because the leftmost plus is executed first, then the rightmost. But it is not mandatory, always it will happen. I mean, if I just change this grammar a little, for example, instead of writing e to e plus t, if I write e to like this, e to t plus e, or t and t to, same thing I'm writing, okay, t to t star f, or f, then f to id. For this particular grammar, obviously I can generate id plus id plus id this string, but here if I want to generate, how the parse tree will look like, I will have something like this, right? Like t plus e, then it is again t plus e, then I will write this e as t, this t as f, this f as id, this t as f, this f as id, this t as f, f as id. Now you see, it's just a mirror image. I can understand. Obviously, I hope you can understand also. But one thing you see, that in this case, definitely this is not possible to compute until and unless you compute this e. That means this e will be computed first, this e will be computed second time, and this e is associated with the plus which is present in the right side of the expression. So what you can say, according to this grammar, plus is right associative. But one thing is common in both cases. Can you tell me what? That is always the node present in the higher level executed first than the lower level. This is common, right? Now you see that, so that is the common part. Fine. But question is that how we will understand that whether the plus that you have in your expression is right associative or left associative. Just try to compare the production rule that I have written over here with this particular tree and the production rule that I have written here with this particular tree. You see that since E is present in the left hand side, the LHS of the production is equal to the, what I mean to say is that the the LHS of the production rule is present in the right side as a leftmost character, right? And if it is so, it becomes a left associative because it is a left associative, right? And this is what right associative. So if the production, if the character, or sorry, if the the symbol that is present in the LHS of a production rule is same as the leftmost character of the right hand side part of the same production, then you can say that that particular production will create a left associative rule. And if it is just opposite one, you see in the other case what I have done, I have just inverted the position of E in the right hand side part. I've kept E in the rightmost as a rightmost character of the RHS, and it becomes right associative. So whether your plus is left associative or right associative, it will entirely depend upon the left hand side character is present in the left of plus or in the right of plus. You see, E is present in the left of plus, that's why it becomes left associative. In the other next production rule here, E is present in the right of plus, that's why it becomes right associative. Ultimately I can see the result. So in this way you can understand the associativity. But this is point number one. Now what about precedence? If I consider to design ID star ID plus ID using this first production rule, then how it will look like? How it will look like? If I want to design, I will have to design something like that. Means again, let's draw the grammar here. Just I'm writing the grammar for your reference. E to E plus T, right? And say T, then T to T star F or F and F to ID. Fine. And using this, if my intention is to draw the string like ID. Let's draw it ID star ID plus ID. By the way, what is this? What is the associativity for this star over here? Over here, can anybody say? So the answer is the star is left associative, right? Because T is present, the LHS symbol is present in the left side of star. Anyway, so now if I want to design, if I want to, somehow want to find the expression of this, the part 3 for this expression, how it will look like? Obviously I will start from E. What I can do, I can I have to have this start in the left hand side, so definitely um, E can be okay, let's draw it here. E can be written as E plus T, there is no other way. Fine. And then this plus, this E can be written as I'm sorry, this T can be written as T star F. Okay. T can be written as T star F. No, I'll not write this one. I'll write E to T, and this T can be written as T star F. And then this T can be written as F, it can be written as ID, this F can be written as ID, this T can be written as F can be written as ID. Right. So in this way you can create this. Now you see, since you, if you want to parse this, what you will see that definitely this T will be calculated first. That means then this E will be calculated. Then using these two, this E will be calculated. So that means this is 1, then 2, then 3. I'm just writing, numbering it just to show you that calculation order. Obviously there will be calculation in F side, F, T in other cases, but I'm not considering those calculations because those are less important to understand what will be the precedence here. So with respect to this, precedence of this T having 1 will have the highest one, and precedence of E having 3 is the lowest one. And this T is associated with the star operation, T star F. That means, according to your grammar, precedence of star is higher than plus. But it is not mandatory that always it has to be maintained. For example, if I design another production rule like this, like E to say E star T or T, then T to T plus F or F and F to ID. Then if I want to design a parse tree for the same string ID plus ID star ID plus ID, then how I can do this? I will simply use a production rule, a parse tree like this, E to E star T, this T to T plus F, and this E is associated with T, T is associated with F associated with ID. This is associated with F associated with ID. This F is associated with ID, like this, right? But one thing you see here, that when you will parse this E is not possible to calculate unless you have calculated this T part. That means this will be calculated first. Obviously, you know, we have seen this. The higher level is calculated first, then the lower level, then this one. And interestingly, the T which is calculated first is associated with the plus operation. That means in this case, precedence of plus is higher than star. So there is no mandatory rule for having this precedence in a particular language. We use star as higher precedence than plus because it is actually maintained as a universal truth worldwide. You may design your own language where you can keep a rule that plus should be calculated first. There is, you know, theoretically, you have no foundation for that. That means if a grammar is given to you with some semantic rule, you have to check according to the rule what's happening and in which order they are present, the production rules. Depends on that, you have to find the result of some string.